You're welcome back to another section still on lowest common multiples. We've dealt with the tabular method in the previous class. Today I want to show you how to go about your exponential method. We shall be using the prime factors of these numbers but expressing them in their exponential form or index form. We shall be using the prime factors of these numbers but expressing them in their exponential form or index form. And for LCM, we are going to deal or pick out the numbers or the factors that have the highest index, multiply them to have a final result. For ACF, we picked out the number that have the lowest powers or the lowest exponents, and those are the factors that we used. But for LCM, we shall pick out the factors that have the highest power, and those are the factors that we'll be multiplying to get our LCM. Let's start with the first question. Find the LCM of 6 and 10. Expressing 6 as 2 times 3, that will be 2 raised to the power 1 times 3 raised to the power 1. 10 as 2 times 5, that will be 2 raised to the power 1 times 5 raised to the power 1. There's no 5 here, I'll add 5 to the power 0. There's no 3 here, I'll add 3 to the power 0. Now they all have 2, they all have 3, they all have 5. But our LCM would be the ones with the highest power. In the families of 2, they both have the same power, so I'll just pick 1, 2 raised to the power 1. In the families of 3, the one has power 1 and one has power 0, so I'll pick the one with power 1, that is the highest. In the families of 5, one has power 0 and one has power 1, I'll pick the one with power 1. So our LCM will be, this is the exponential answer. If you ask to keep your answer in index form, if you ask find the LCM of 6 and 10, leaving your answer in index form or exponential form, this is the answer you should leave it at. 2 raised to the power 1 times 3 raised to the power 1 times 5 raised to the power 1. But if you're not asked that, your answer could also be expressed as 2 raised to the power 1 is 2 times 3 raised to the power 1 is 3 times 5 raised to the power 1 is 5. So that will be 2 times 3 is 6 times 5 is 30. So our answer is 30. So the LCM of 6 and 10 is 30 using the exponential method. Let's see the next question. What is the LCM of 8, 16 and 20? 8, 16 and 20. Express 8 as 2 times 2 times 2, that will be 2 raised to the power 3. 16 as 2 times 2 times 2 times 2, that will be 2 to the power 4. 20 as 2 times 2 times 5, that will be 2 raised to the power 2 times 5 raised to the power 1. There's no 5 here, I will add 5 to the power 0. There's no 5 here, I will add 5 to the power 0. They all have 2, they all have 5. So our LCM will be equal to the ones with the highest power. In the families of 2, this is the highest power, 2 to the power 4, times in the families of 5, this is the highest power, 5 to the power 1. This is your final answer in index form or exponential form. But if you're not asked to put your answer in index form, then our LCM could also be expressed as 2 to the power 4 is 2 times 2 times 2 times 2, 5 to the power 1 is 5. This is 4, 8, 16 times 5. 16 times 5 is 80. So our answer is 80. So the LCM of 8, 16 and 20 is 80. Now, use the exponential method yourself. Find the LCM of 3, 5, 20 and 36. In the previous class, we've dealt with it using the tabular method. You solve it now using the exponential method. Express your numbers in exponential form and pick out the ones with the highest powers. And ensure you fill up all the spaces that do not have numbers that are found in other areas, raising them to power 0. If you've done that, pick up the ones with the highest power, then multiply them to get your final result. So carefully go with this, do it and get the answer and forward it to me on the WhatsApp platform. See you in our next